Okay, so got my terrain mountain. I want a new object, and this is going to be my forest. I'm going to name this forest. And then we need another object, tab geo, to get a geometry object. And I'm going to name this tree, because we need to bring in our tree. So I'm going to go inside my tree object, and I have a file node. And then I go and I select, if you look at where my mouse is, right here, I'm going to click on that. And I saved everything on the desktop, including my geo folder. So it goes right to where I saved my file, and I see my geo folder. I open that up. I open up the tree folder. And I have two tree files, but since I named them tree 1 and tree 2, they come up as a sequence. Like, it's kind of like Nuke or a compositing software that just like has the whole sequence in one line. In order to see the individual trees, I need to click this off and show sequences as one entry. Turn that off, and then you'll see the individual trees. And I'm gonna click tree 1. Comes in really tiny, so I press space G to home my tree so I can see my tree.
When I hit tab tree and like typed in tree, nothing came up.
It's not a tab though. So when are you looking for your tree file?
Yeah.
So you have to the file node comes with your geometry object. So just make sure you've got that file selected first. Okay. Good. Now we want to color our tree. Tab color. Let's change that color to like a nice green, or not. You don't, it could be from another planet. You can have a pink tree. This is the beauty of CG. And we're gonna probably change this later, but right now we've got a green tree. Alt, drag the color node, and then connect it. I want another color. I want color 1, color 2 underneath it. But this time, when you work in other softwares and bring in models from other softwares and group put groups. They come into Houdini. The groups come into Houdini. This guy actually has a group, and if you lower the arrow, it says trunk. And now color 2, I can change it to like a brown, and now I've got the bottom of my tree is now brown. Fall color tree. Okay, let's look at the information, the I information on this node. What do we see? 44,000 polygons. Now, if we want to instance this tree thousands of times, I don't know how fast these computers are, but we might run into problems, right? So we're going to do something called packing, where we pack the tree and basically it gets stored in memory. Tab pack. And now let's look at the I, and now we've got one polygon, 1.1, one packed geo. So the memory footprint just went really far down there. 8K, we went from how many K? We went from 4.8 megs to 8K, to 8 kilobytes. That's what we just did. Now, I encourage you guys to read about packed. Here's how to get to help. There's a couple ways to get to your help. With your node selected, in your parameters, there's a little question mark at the top right of your parameters. That will bring up the help card of each node. And this is a pretty big help card, and it explains how packing works. But it's important that we colored it before we packed it, because after we pack it, you can't color it. Because all the attributes you're not allowed to like add attributes after you pack it. So you want to put your attributes, your color attributes on before you pack. But feel free to read about all this good stuff, and it becomes a big deal for destruction, because all of your fragments are packed fragments for destruction. So when this was released in Houdini, it was a big deal because it sped up a lot of workflows. Okay, so we pack this guy, and again, we want to import it. We're going to import it into our forest. What do we do at the end of a network? Anyone remember? Good job. Is that May? Who has that? That's that. Regine. Put down a null. I just put my nulls as black. I don't know. I like them as different colors because it just marks the end of my network. We're going to say tree, all uppercase, underscore out. Okay. So let's go back to our forest. go inside of our forest. And we have 2 trees, so at the end of this we're gonna do a little 2 tree, we're gonna add the second tree in after we have everything set up. So go inside your forest, and again, remember when we make an empty geometry container, all it gives you is this file. Delete this file, we don't want that file. A file is when we kind of import piece of geometry from disk, right? But we don't want to, this time, we want to get our terrain that we made. So we use a different node, and that node is called Object Merge. Tab Object Merge. This is how we import other networks into our new network. Object Merge. In the parameters of your object merge, go to object 1 all the way to the right. You've got a chooser. Now we go into our terrain, and look, that null that we made goes all the way to the top. So easy to find. Why? Because it's all uppercase. That's why we did uppercase. Uppercase nodes always go to the top of the list. So it's like, otherwise it'd be so hard to find. Yeah. I love how helpful all you guys are. You froze? Rainbow duck? You've got the rainbow duck. I can airdrop my file to you.
I already have the file.
Okay, you saved it.
Mm-hmm. And do you have it with the trees?
No.
Okay.
Sorry, so what?
Is your file with the trees?
Did I what?
Well, you said yeah, can you save your hit file? Between?
Yeah.
I'm number 6. Thank you.
You want me to airdrop it to you?
Yeah, that'd be great.
No problem. What number are you?
6.
I love this airdrop thing.
No, never mind. I just unfroze. I'm good. I'm good.
I'm just gonna give it to you anyway, just for
Okay.
just for kicks.
Thank you.
Good? Okay.
Yeah, might be because I got 2 trees and terrain that I all just merged. Everyone good?
Okay, so I've got this terrain out null. So not only does it make it easier to find when it's uppercase and a null, but what if I didn't have that null and it's like you'd have to find the bottom of that network. So I can jump to that network just by clicking on that icon, that arrow icon, and it jumps me into my actual terrain. If I did not have my anchor here, my null anchor, I would have to kind of figure out what the last node of my network was. And then what if I forgot that this was connected to another network and I started to put other nodes below it, and then my new network wouldn't know, oh, she added 3 more nodes. So it's very important. It's like, this is just the way it works. Like, you always put a null at the end of your network if you know you're going to be importing it somewhere else. And then object merge always gets the null. So that's just the workflow. So now we've got, in some ways it's like a duplicate. It's like we now have this forest that we made somewhere else. I mean, this terrain we made somewhere else, bringing it in, and we're going to do something else with it, right? Okay. Let's see. Object merge. Here's the deal. I want you to put down a scatter node. Tab, scatter. What does the scatter do? Scatter makes a point cloud. And these are going to end up being the points that we instance our trees on. Pretty convenient. It's a good time to talk about your point display. If you look where my mouse is, there's a little point icon, and that'll help you to view your points a little better if they're colored like mine. Okay. One thing is that's controlling the amount of points you have is this forced total count of 1,000 points. Go ahead and put another 0 there. And now you can see you've got a lot more points on your mountain. I'm gonna keep my points nice and ordered like this, but if you want, because you know, it's kind of nice because then I know my trees won't be on top of each other. However, you can always take out this relax, and that makes them random. The points are more random this way. You turn back relax, and everything is orderly. If you want, you can blend it, so you can make it like you just turn down the relaxing a little bit, and that'll give you a little bit of both. You just blend in a little bit more of the randomness in there. So we're gonna change kind of like the distribution. We're gonna change the distribution of these points. But we'll do that after we actually copy the trees, because let's get to the reward kind of soon. So first, let's just copy these guys on. Okay, the copy SOP is my favorite node in Houdini, and it's basically what converted me back in the day. The copy node used to be one node, the copy SOP, but now it's 3 different nodes. Let's see. Oh yeah, okay. We're gonna use so if I say tab, copy, we've got 3 different copies: copy and transform, copy stamp, and copy to points. Copy stamp is copy to points, but with some extra functionality. And we might use that. So let's do copy stamp. Okay. Copy is copy to points. Before we connect anything, we need to bring in our tree. Tab. Another object merge. We go to object 1, same deal. Open up your tree, and again, our null, all uppercase, is our first one. Set that. And I'm going to take off my point display now. So if you hover over the inputs, it tells you what it wants. I hover over this one. If I hover over this one, it says required primitives to copy. And this one is, now unfortunately, this one, the message is down below. template to copy to. When it says template, it just means the points, you know, template points. I'm not, you know, some of this language is a little confusing, but it's just points. So we go like this. We just click the scatter here, and we click the tree here, and we, and then we've got our copy. Now this is packed. So that's why I'm able to even tumble around here. And keep in mind that all these copy nodes, if you look at the copy and go to the next tab called stamp, it says pack geometry before copying. But I like to pack it before, because if I forget to click that on before I wire the nodes, I've crashed my computer. So just always pack first, I think.
No, that you will crash.
It's already packed.
So, okay, what do you after we create an object those two? In case something is really quick, right?
Let me see what's going on. Oh, okay, I'm going too fast. This is the tree. Okay, I'll go slower.
I got kind of lost because everything disappeared, so I was trying to catch up.
No worries. I'm gonna catch you up right now.
Oh,
Press space G right there. Space G there. Now we got it. Space G. Oh, we got. I see it. Okay, good. Okay, another object merge. Actually, we can just press Alt. Drag this guy. Tree. Scatter, and it looks like these computers want to look quite a bit more. Really good.
okay.
Really good resolution. Anyone else need help? You guys are good? Okay. Okay. Let's go to the render view at the top here, and I'm gonna hit render. Let's get a light in here. So I'm gonna press Command, click an environment light on the top right shelf here. Let's go back to render view. And now we've got our trees. These computers seem to be quite nice. If you at home don't have a fast computer, there's one more thing you can do. So here's my tree. Let's name our object merges. So we have tree there, and we've got forest here. If I select my tree and I hit this icon, which is like the jump to icon, I jump back to my tree. If you go to your pack, there's an option to display as a bounding box instead of the tree. And that way we can speed up things a little, even more. We can speed things up. Let's go back into our forest. And now we've got boxes. Okay, a couple things that we want to do to our forest. But first of all, let's take a look at our render just one more time. I'm going to render it. You'll notice the boxes have no effect on the rendering because when it renders, it unpacks. If you go to your environment light, I want you to say render light geometry so that we've got like a background. Render light geometry in your environment light. One thing you can also do is hold down Shift and draw a box in your render view so that it will only render that little area. Hold down Shift, draw a box, and it will only render in that area in your render view. Now we really can see how. Need help? Yeah? Cool. Now you can see how regular the trees look, right? We want to do a bunch of stuff to fix that. But let's just show one more thing about lighting before we do that. Okay, so sky environment map. Right next to render options, the sky environment map. I want you to say enable. Underneath here it says use, and then it says rotate angles, and say location, date, and time. I'm going to take my shift away actually. So shift, click outside of the box, and then the whole thing renders again. I'm going to take my light intensity up and my exposure. The exposure is like more of an exponential curve than light intensity. which I find gives me a little more contrast, so I like that sometimes. Now here's what's cool. Latitude, longitude, date, and time. So right now we're like in the middle of the ocean, or we might be in Ecuador, I'm not sure. But you can go to Google Maps and like find the place that you want the longitude and latitude of. And so I'm just gonna like pick a random, but what I like also is to change the time. So I'm gonna say 4 p.m. and then I start to get some nicer. I mean, it's still not like a true sunset. Like, I want to figure that out, but that's not for today. And then I can continue to kind of bring up the light intensity, and I can change it to more of a, you know, I can put a little pink in there to kind of compensate for the yellow and kind of make something a little more dreamy, you know what I mean? So I'm just gonna bring up my yeah, something like that. Cool. We'll Instagram it, right? A little bit. And again, I'm just going to now take shift, draw a little box so I can see what I'm working with. And I get my trees back. Very regular, very regular. Okay, but now we've got everything set up so that when we make changes, we can see it in the render, which is more fun. We don't even have shaders on these guys yet. We're just like, under the hood, it's putting some default shader on there, but we'll do that soon. See, what's really neat is like when we get, if I'm gonna make a camera soon, but these are the edges, and I like that kind of, it gets a little bit of a rim lighting here. Okay, so why don't we do that? So go back to scene view. Right where my mouse is, do you see where it says no cam? Upper right says no cam. I want you to say new camera. New camera. Now we just made a new camera. And it has to be locked, or else, and like now when we zoom around, we're in our camera. But if you unlock it and start to move, you're not in your camera anymore. You're just like tumbling in display mode. So I'm gonna go back to the new camera I made, lock it, zoom in a little bit, and now when I hit render, I'm gonna hit shift and I'm gonna hit render. I can kind of see the profile. I feel like the trees look a little big to me. Could be a little smaller. But we're going to deal with that now. Okay. So, I'm going to stop my render. Now, you must stop it or else, like, if you go out of your render view and you start working, and it's still rendering in the background, and that's going to slow you guys down. So you must stop your render view from rendering when you don't want to render. I go back into my forest, and I'm gonna work on what's bugging me the most first, and then we're gonna keep moving on. So here's what I want to do. I want random scale, and I want random rotation, and I want to control the distribution. Those are the three things that we're gonna do to make our forest really cool. So remember we talked about attributes. That's all what this is. So I'm going to say tab point. And make sure on your copy node that you've got use template point attributes on, so that all of the attributes come down. So use template point attributes on your copy in the attribute tab. Okay, here we go. This point attribute, I'm going to rename it to random scale. And I'm going to say attribute is, and it asks you what kind of attribute do you want. These are like really common attributes that Houdini knows about, so we don't need to make a custom one because it's got one ready for you called scale, p-scale, point, which is point scale. So I'm just going to turn that one on, and automatically everything goes to 0. So now all of our trees are gone because the scale is now 0. So we have to put our scale values in there. So under this vexpression, we're gonna do, I'm actually just gonna type it, rand at, the at symbol, ptnum and now we've got randomness. We've got our trees totally random. Wonder if I can make this bigger by expression edit string. It's not even bigger, but yeah. So rand ptnum, rand open parenthesis at ptnum close parenthesis. Raise your hand if you do not have this. Okay. Okay. So let me give you my file. What number computer are you? 12. I see it. I see it. So everyone has random trees, random sizes, yeah? So let's render them. Yeah, so got some babies and some big ones. I'm gonna check my colors because they feel a little off to me.
Command option equals. Yeah.
Command option equals. Aha. Good job. Okay, I'm just checking. I'll turn that back in a sec, but okay. Now, what if we wanted to control the distribution of the size of our random trees? So it gets pretty detailed, right? Like right now it's just like, oh, before I even go there, I need to explain what rand pt num is. We've got Photoshop here, right?
Yeah.
I need to, or is there something where I could just make drawings really quick that's even lighter than Photoshop?
Not that I know.
Okay.
Anyone know if there's something built in? Okay, I'm gonna go with now.
Command space bar.
Yep.
Okay. Okay, so let me talk about what this is. So let's say you've got a sphere and you've got points on your sphere, okay? Each point has a number, let's say, 3, and let's say like this is 402, they just range depending on how much topology you have, how much resolution you have. You're just going to have a whole bunch of point numbers, right? Point numbers is at pt num. The at, whenever you see at, that signifies vex. Whenever you see $, that's H script. So I know this is super confusing when you're just learning Houdini, but vex is kind of a newer way to work, where it's like H script is a scripting language. It's like you have expressions. You have expressions in both. You have functions in both. But Vex is faster. It's multi-threaded, and it's we use Vex where we can. And a lot of parameters, you'll see H-script though. You can put H-script directly in parameters, just like we saw $F. It goes directly in parameters. So my point is you're going to see these things in different places in Houdini. But basically, this is how we add little expressions and functions in Houdini. So putting this aside, whether it's Vex or H-script, I just wanted to explain why you're seeing the @ sign. The @ sign signifies that it's a Vex function, Vex expression. So @PTNum means point number. It just returns your point number. Whatever your point number is, I could be 0.1, I could be 0.2, doesn't matter. That's what it's going to return. These are just like, you can think about them like variables, but they're really just attributes that, it just returns the attribute value. They're like pointers. They look up. They look up the attribute value and they return the attribute value. So @PTNum, point number. So what is rand? Rand is a function. And it's a function that returns a pseudo random number between 0 and 1. So it's a fraction. So whether you've got 0.1, 0.2, 0.3, 0.4 up to 0.10,000, if you put rand @PTNum, it's going to give you a random number between 0 and 1. Doesn't matter how high these PTNums, how high these point numbers go. It's always going to be between 0 and 1. Where does the pseudo come in? The pseudo means that, let's say I say rand 5 and I get like, I'm just making this up, like 1762, something like that. Let's say I run that again somewhere else, rand 5. The pseudo part means I'm going to get that same exact number back. Pure randomness means it's going to be a different number, right? So it's pseudo random in the sense that it's always going to give that particular number the same random number. And you want that, or else you're how would you be able to direct your effects? I mean, it would just be insane. So pseudo randomness is what we've got. And then once it runs through the random function, I'm 0.1 and I have this random number, that value is then applied to my point scale. So now I've got a unique random scale based on my point number. Does that make sense? Cool. But, a lot of you can even look this up. People have studied, the distribution of tree length, in a forest. You could have it's not a linear curve from small trees to large trees. It could be, a curve like that or like that. So, and whenever you're doing, world building, you want to think about distribution in every sense. We're going to be doing that a lot here. So distribution, let's do size distribution. So I'm going to dive you guys right into it. We're going to do a really simple thing, and it's a brand new context called VOPS. And VOPS uses Vex. So under your random scale, I want you to say tab VOP, and we're going to make a custom node. I'm gonna call this size distribution.
What was the thing that you did?
Attribute Bob.
POP, right?
Hmm?
POP.
I couldn't hear you.
POP for this one.
VOP. VOP. VOP with a V. Point VOP or attribute VOP. Either one is good. It's the same node. Okay, everybody have their VOP ready?
Is this in forest or?
Yeah, we're still in forest. And I want to zoom in so I really see like the different sizes. Someone said crash.
You crash?
Why don't I airdrop mine to you?
Okay, just you. Number 9.
Okay, you got it. And I'll do it again because I know you have to open the file. Let's go into our size distribution. Now, I know this might look a little scary, but don't worry. You didn't get it? Oh yeah, it keeps saying waiting, waiting, waiting. You have to accept it. It's waiting for you to accept.
On the top corner, top.
Are you visible? Because I don't see you. Eh?
She got it.
Okay.
So again, VOPS is like we're dealing with attributes. In both of these guys, we're dealing with attributes. So like the point one, if you look here, we're dealing with attributes. If you go into VOPS, same deal. You're dealing with attributes. Point, velocity, age, scales, color, normal. These are all attributes. Okay, so we made a p-scale attribute. So let's go here. I'm going to go to my view and I'm going to say hide all attributes and I'm going to say only look at p-scale. So view, hide all attributes, p-scale. And you'll now see that each point number has a unique value. I'm going to say tab bind. Bind is a VOP node that we use to bring in attributes. Because you see, I don't have p-scale, I do not have on this list here. So I need to bring in my attribute if I want to manipulate it. I'm going to say p-scale here. Because that's the name of the attribute. Now one thing that's confusing, yeah.
Sorry, mine doesn't bring that. You're on the. Wait, you know what? Yeah, I was wrong. I'm sorry. It's all good. And then just go view, hide, or
Just to see? Yeah. Oh, I think I clicked on the wrong thing. So, just a reminder, that p-scale itself is the name of the attribute, but but when we call it, when we look up the attribute, it's at p-scale. So this can be kind of confusing. I'll just say value there, name value. Attributes are confusing in the beginning, so don't worry if this is not easy stuff. So I bring in my attribute based on the name. And then what I want is like a ramp, tab, ramp, tab, ramp. And then I want to take it out again, tab, bind, export, bind, export. You can think about bind as like the glue that holds the attribute to the geometry. And again, this is going to be called p-scale. Now, if you go to your ramp, make sure that the ramp type is spline. Remind me of the magnifying thing.
Command alt equals.
Spline. Make sure it's spline. Yeah.
I'm sorry, how do you get the ramp thing?
Tab. Tab. Tab ramp. Oh dear.
Same.
Because I'm not finding one that's just called ramp. I'm finding ramp.
Do tab ramp.
Oh, sorry. Ramp parameter. It's a ramp parameter.
Yeah, find two. Actually, find two doesn't give me the option. That's an option.
Right. Okay, so that's a bind. It's
You need bond export.
yeah, bind expert. However, so you can see if I use your action.
I can see it. It feels so loose.
Don't worry. I'm using my effort. Yeah.
Export. And now it's a bind export. Yeah.
You good, Marcel? I think so. Yes. You need bond export, not bond. So delete it.
Yeah.
And should do tab ramp. No, that's the right way. It's bind, then you bind export. The second one. And then you have the enter where it's trying to present it. And just call that p-scale. Yes.
Do I want to get an input?
Yeah, that's fine. Yeah, it just means that you can't connect it. That's the only difference.
Okay. So the label. What do we want to call this? Let's name it size. Now we go back to the top level. And by default, it just kind of makes everything. but this is where we were. We've got a linear distribution. So if you move your ramp, you can see that the size changes. So if I wanted more medium trees, I could like bring the babies up so they're not so tiny. I can take the large ones down so they're not so big, and I can like, you know, change the middle one. You can even change the interpolation so it's curvy. So start playing with that ramp. Do you see what's happening? Do you see it? Yeah? Is this cool? You guys having fun, or is it too crazy? Too many details.
I feel like this is stuff that's it's not
Okay. So if you look, it says default. That's not what we want. What we want is number 16.
Jeff, how many are your order?
Yep. Okay, you got it.
The ramp's not changing the scale.
Oh, okay, no problem.
Okay, I just put my file on your computer. Okay. Next, let's see. Well, first let's see how this renders. I'm just gonna pretend I'm happy with it. And I'm actually gonna see if I can get even more trees on here since I've got smaller trees now. I'm gonna kind of test the power of this machine a little bit and add another 0. In my scatter, the force total count. Oh, too much. Gonna do 50,000. Gonna do 25,000. Gonna settle on 30,000. And I'll probably tweak that size curve a bit later. So let's say that this is a good amount. Let's go in and let's zoom in a little bit more. Draw a box so you can really get a render going faster. And we're still seeing a lot of regularity. Even though we helped it with the scale, random rotation of each tree is going to help us a lot. So let's do that now. Random rotation. Tab point. Tab point. Which I'm going to rename random rotation. This node is really called attribute expression. It's just called point when you press the tab menu. Reason why they do that is because they want to replace the old point SOP, but this is really an attribute expression SOP. It actually replaces 2 SOPs, the attribute create and the point SOP. It's just like, yeah, there's a lot of like every version there's new stuff to adapt to. So, bless you. Okay. P scale is a 1 float, right? We get that, right? 1 float. It's not 3 numbers, just 1 number that controls the scale. It's not like color that has RGB. It's not like point that has XYZ or normal that has XYZ. It's just 1 float, 1 number that controls the scale. That's a 1 float. What we're gonna do now for random rotation. Rotation needs a little bit more. It is actually a 4 float. It's what we call a quaternion, and the reason it's 4 is because the first 3 is the axis. So let's say I'm a tree and my axis is 0, 1, 0. I've got 1 going up in Y, right? 0, 1, 0. But that extra number, that 4th number, is the spin. Okay? And what's neat is that that last 4th number, if we make that random, and we figured out how to make randomness with the rand PT, with the scale, we're going to use the exact same thing for random rotation in that 4th number to give it random spin. And it's convenient because that random spin will receive the range from 0 to 1. The random function always gives us values from 0 to 1. There's a lot of ranges in Houdini that's 0 to 1. It's normalized. It's like things are normalized in Houdini for a reason. 0 to 1 ranges. So the random function gives us values from 0 to 1. Very convenient for us. We take those, I know it's a little confusing, ranges, data ranges, right? So we work in ranges, like I'm going to go into this more soon, but the range of the random function, the range of values that the random function gives us is from 0 to 1. And we're going to use that range to rotate each tree randomly. So when I'm at my random rotation, I put it before the scale by accident. It can be below or above, doesn't matter. Random rotation. Now, the attribute is not listed here. It's not listed here. But it's an attribute that Houdini still knows about. It's an attribute that if you call it by its right name, Houdini will know what to do with it. Like all of these are attributes Houdini knows and knows how to use them properly. But it's just not listed, so we say custom. I still forget the zoom in. I'm sorry.
Command Alt equals.
We're going to call this ROT for rotation. That's what it knows. And then the type, we'll call it vector 4. I mean, it's the same thing as float 4, vector 4. It's 4. It's a size 4. It's 4 values. So here we're going to say, one second. So here we're going to say 1 and 1 because we know that our tree is 0, 1, 0. But we're going to put an expression here that's going to multiply all of this. And when you multiply something by 1, what do you get? So that's why we use 1 here. And as long as these are zeros on X and Z, we're good. So we only care about Y and this 4th spin. Okay, so I gotta zoom. Well, let's see if I can do it with my mouse. Okay, here we go. Rand at pt num, close the quote, times value. Value is this 0, 1, 0, 1. I'm going to put a sticky chase of that little thing. Sticky notes. And tell me again, my memory's just shot.
Command Alt equals.
Command. Okay. Okay. Now put your display flag on your copy, go to your render view, and see if you've got your rotation. I think it let me check one more thing. If I go to my scene view and I go to the top, yeah, see that? All my cubes are rotated. Pretty cool. Regina agrees with me. We're not going to do it. We don't need a ramp for that because we're good with the random rotation we have. We're going to stop for lunch at 1 o'clock, and so I think we can finish our forest. But there's one thing I definitely want to do, and one thing that I'm hoping we can do. Okay. Density, distribution. Okay. Let's talk about that. Oh, actually, there's 3 more things I want to do, hopefully. Okay. Let's zoom out. Okay, so we zoom out. And what are we noticing? It's like, doesn't it bug you that the trees are like covering the forest like so homogeneously, like just so like, you know, there's no break. There's no kind of like more on the bottom, less on the top. So we really have to fix that because no forest on this planet looks like that. I mean, it still looks pretty good for only having 1 tree, but let me get a better view. Okay, so this is where we start working with what's called the density attribute. Now, that's all the way up here in our scatter. If you look at the scatter parameters, you'll see that there's a little checkbox for density attribute. And we want to turn that on, but we need to create it. You need to create the density attribute first, or else you'll get a big error. I'll turn that on and big error, big error. Why? There's no density attribute, and it's like you turned it on, but you're not there. Okay. Now, in Houdini, you can make attributes in a lot of ways. We can make attributes with this attribute expression, with attribute vops, with attribute wrangles. There's a lot of ways that you make attributes in Houdini. For this, some things are, you know, for this one I'm going to use a VOP because some things are a little easier, you know, depending on what it is. However, I want to just show you one cool trick. Let's do one thing really quick. Actually, let's do another point. But when you make your density attribute, it has to be above the scatter because the scatter has to receive it. If you put it after the scatter, it won't know, you know, it won't find it because it's after the scatter. So you gotta put it before. Let's put that there. We'll call that density. Um, so this one is a custom attribute. And I'm just gonna call it density. Instead of P, call it density. And right away, I can now turn it on. I can now turn that back on in my attribute. But nothing happens because I haven't put any values in there. But I'm not getting any errors anymore because I created the density attribute. You can see it right here. And by the way, it is not a vector. It is not a 3 float. It is a float. It's one float. So make sure that type is float. So we're making this density attribute. Now here's what's kind of cool. Like, remember I pointed out how we have these, like, we got these attributes for free? Bedrock, debris, flow. Let's take a look at bedrock. So we have our bedrock here. And let's see what happens when we use it. So I'm just going to say at bedrock, because at bedrock, the name of the attribute is bedrock, but when we look up the values, we have to put the at symbol. And now what we're doing is we're piping the bedrock values. We're taking one attribute, we're taking the values of one attribute and we're shoving it into another attribute, the density attribute. Taking the bedrock attribute, taking those values, putting it into the density attribute, and now take a look at that. Take a look at that. So for free, we got all of this for free. Now, but there's a problem. There's a problem. Remember I talked about ranges. If you look at the geometry spreadsheet, bedrock goes from -62 to +356. So we're not, the problem is density. The density attribute in the scatter only deals with the values from 0 to 1. So we need to remap these bedrock values. And there's a bunch of ways we could do that, but I'm thinking, let's try this. I don't like to hard code things because things might change, but it's okay. Let's try this. Gonna do another expression. Let's try to do this. We're gonna fit. We're doing a fit function. A fit function takes a value, looks at the old min and max, remaps it to a new min and max. In our case, our new one is 0 to 1. We want to remap the values of -65, I think it was, to +356. Take those values, remap them to 0 and 1. Does that make sense? Because I can draw a diagram if not. So we say fit at bedrock. This is just from memory, but I think it was -60. I'll just say 65 for safety, comma 356. The old min and max. That's the old min and max. New 0 to 1. We want to map it from 0 to 1. So let's see what happens. Okay, so let's see what other attributes we've got. Bedrock, flow. Let's see what flow has. Where did my attributes go? That's weird. View. Huh? Okay, let's look at flow. Flow goes from 0 to 75. So we'll say at flow, so there's a way to avoid typing in all of these stuff, but for now. Okay, take a look at flow. That's kind of cool, right? So what if we had all of our trees just in these like flow crevices? So basically you can take an attribute and just like base it on stuff. A lot of times what I do is I like do it based on height and I expose the top of it. But yeah, there's a lot we could do with that. And it's just, if you wanted to do the height, you would just like do it based on the bounding box of the whole thing. But I think this looks cool. We'll keep this one. Yeah, you agree? I'm pretty happy with this one. Let's do this one. Okay. Let me zoom out a little bit. And of course you can apply the same exact ramp that we did with size and say, hey, I want to give preference to different areas, like from 0 to 1. And you can also take this and multiply it by the bounding box. You can mix two of them together, you know, but we could spend all day on this, so we have to choose our stuff. So okay, last thing, because I wanted two more things. Okay, we want 2 different trees. Let's say you want 2 different trees. Go to the top level. Oh, by the way, is everyone good? Does anyone need help? You need help? No, it's fine. Okay, so next, take the tree that you've got, hold down Alt, and drag it down to make another tree. Open up the next tree, go to your file 1, go to your geometry file, and click on tree 2. Choose a different color so we can test that it's working. Then go to your forest. Open up your forest. Am I going too fast? I feel like people, yeah? So let me just, I'll come around, but just all I did was I pressed Alt on this tree. I hold down Alt and I drag that tree. So I made 2 trees. I'm on the top scene level. The top scene level. Go inside the second tree, select the second tree, tree 2, and color it a little different. You don't have to worry about that one. Yeah, just that tree. And the colors are all gonna change in the end anyway.
I changed the color, but I don't see any difference.
We haven't brought the second tree in yet.
Oh, okay.
We're still. Okay. Next, go to your forest. I want you, same thing with the object merge that brought in that tree. I want you to Alt drag here as well to make a second object merge tree. Press P for your parameters, but this time I want you to go to tree 1 and get your tree out. You can just put a 1 right there. You can see that the bounding box is a little different. You know that it's working. Okay, next I want you to put a switch node, tab switch. Tab switch. If you click on a node by accident with the tab menu, just press escape to get out of that. I do that a lot. So let's put the 2 trees together in a switch. And all the switch does is it switches between the 2 objects. So if you go 0, 1, 0, 1 on the switch, that's what it's doing. It's just switching. It's a pretty handy little tool, node.
So, did we just make a copy of the tree?
You did,
Okay,
but you brought in the other tree though.
yes.
Yes. Yeah.
Sorry, how do you bring in your tree?
Huh?
What's the node to bring in the other tree?
So it's just the same node. It's object merge. But you just have to make sure that you're selecting the null of the second tree.
Right.
Cool. Then we're going to put the switch in the input of the copy instead of tree. But here we've got a problem, right? It's still, the switch only shows us one tree or another tree, right? So I'm introducing a new concept. This is why we've got the copy stamp instead of copy to points. We're actually going to use a stamp variable to change something that's flowing upstream in our network. Stamp function. The stamp function. We go to our copy. You must say stamp inputs. Stamp inputs on. Then we make a variable. I'm just going to call it random switch. You just name it, random switch. We need to give it a value. What do we know that's random, that gives us random numbers between 0 and 1? Nope. Nope, no, the function that gives us random numbers between 0 and 1. It's the rand function, right? Yeah. Rand, open quote, rand, open quote, at ptnum, right? This gives us random values between 0 and 1. This is in the stamp tab of the copy stamp.
Sorry, what note is that? What note is that?
Doing is we've got two trees and we want to randomly switch between picking this tree and picking this tree and picking this tree. If I'm a point and I have a value, a random value from the random function less than 0.5, check this out. Okay, we talk about floats and we talk about integers, right? This switch, the switch takes integers, 0, 1, 2, no fractions. It's either this object at the 0 switch, or it's this object when it's 1, this object when it's 2. The switch is switching. The switch only takes integers, no fractions. Makes sense, right? So but my random function gives us integers. Floats, sorry. Decimals, fractions. So if I'm 0.5 and my random function gives me something below 0.5, like 0.25, 5, 7, whatever. I'm below 5, I'm gonna be rounded down to 0. If I'm above 0.5, you know, 0.673, whatever, I'm gonna be rounded up to 1. So that way we can randomly switch between 0, 1, 0, 1, 0, 1, that way. And if, let's say you had 5 trees, you fit the switch to 0 to 5, or you fit the variable. You remap those values. But we're just doing 2 trees today. Makes it easier. So in our switch, we gotta call the stamp function. Did I press record? Do you remember? Oh God.
Sure.
Oh yeah, okay. Stamp. And it kind of helps you here. Stamp, open paren. Now it even tells you what to do. It even gives you an example, I believe. Let's see. Yeah, gives you an example down here. That's your example. Stamp, quote, dot, dot, / because this is like a file system. And we know, we say C, copy 1. I can go down here, enter, copy 1. Close the quote, comma, quote, random _ switch, close the quote, comma. 0 is just like, if there's a problem, it'll just go to that value. It's just like a default. Now let's see if it worked. I'll put this big in a second. Let me just make sure mine works so that there we go. Cool.
You also treat this the same way, just using a merge.
A merge of 2 forests, you mean?
Yeah, where we say 2 object merges. Because initially I did that same thing earlier, but just like a straight up merge into the copy.
You mean 1 forest but 2 trees and they're merged? Is that what you mean?
Yeah, where I had 2 object merges and they go into a merge, and then that merge node just goes into the copy.
But wouldn't you have 2 trees on top of each other?
No, because you do it in a previous geometry node where you just use a translate and translate it over a little bit. So then actually you don't really need to, because you just can have 2 nulls on them, and then each of the object merges has a different null that you're reading from.
But you just translate one over? Is that what you, so,
Yeah.
to get them offset, you mean?
Mm-hmm.
You offset with the translate?
Yeah.
The problem is, that might be easy for 1 tree, but what if you have like 10 trees and you're like, have to offset each?
But would you really need to do that, because you're telling the different trees to be randomized at different points throughout, then you just have different.
Do you have this set up? Can I see it? Do you see how they're right on top of each other though?
Yeah, in certain points they are.
So that's
Yeah,
why,
yeah, 'cause I'm just using merges. With these 2 out.
so you're merging, oh,
Yeah, because I have the 2 different tree geos
but
here.
why do you need to merge them here?
Well, I was just using that so I could see them both.
Oh, so
This
you can
view.
see how they're,
Yeah, because
oh,
I'm doing that.
that's your offset right there?
Yeah, so I offset it to just a little bit so that way I can
The problem that I see is that you're gonna see patterns. You're gonna see the offset. Where this way is purely random, where yours is not quite random. But it's good thinking. I like the way you're thinking. Yeah. And it would be cumbersome to scale up.
Okay, yeah.
To like,
Mhm.
if you want like 100 different trees, you'd have to offset 100 different trees, where this way it's one little fit function and you're good to go. I mean, you wouldn't do 100 trees.
Yeah. Without, like, heavy-
Object merging would be annoying, but,
Yeah.
good, yeah. You've got some errors.
Yeah. Oh,
Instead of that, you need a forward slash, and you also need a quote. Yeah, there we go. Your errors are gone, and so let's see your copy then again. So everyone has 2 trees? Okay, let me know if you have 2 trees.
Houdini crash.
Crash?
Yeah, spinning wheel of death.
Okay.
Same.
2 spinning wheels of death?
Well, I mean, just trying to reset everything.
Okay.
I got 2 trees in, so that's good.
That's super good. Still no work? So your trees is a different color, right?
right, it's like all over the second.
See, they're the same, do you see that? Tree 1,
If you unfreeze,
Oh,
They're exactly
save.
the same
Oh,
tree.
then.
Well, I mean, it's not frozen anymore, but I did not save, and
Yeah,
I have to go back and,
yeah, at this point, I got like 12 saved files.
I got to redo everything.
Yeah, I'm just like, yeah, these are wanting to crash, I'm just like, save, opted. Yeah, I always do like those 3-0 null at the end, just so it's like whatever file name, underscore 001, 002. So you can have 999 saves total.
Yes, but.
Oh, yeah, you have
And then when you
another.
get to the thousands, everything crashes.
Well, once you get close to that, then it's like, okay, so now we rename it to a different tile, 001.
No.
Yeah, okay, so it's like most of
There you
them
go.
have like 3
Yeah.
different names, have like saves.
It's like the 3D artist or whatever.
Okay, I think we can call our forest done for now and go on a lunch break and come back and work on some other stuff.